Okay, so in Intel 8086 microprocessor, the basic feature of 8086 microprocessor is it is a N-channel HMOS microprocessor. So that means it is manufactured by HMOS transistors. Okay, so that means this is the very basic part that we need to understand, or need to take our consideration that how 8086 that chip is manufactured. It is manufactured with the help of HMOS. That means high speed MOS. MOS is a kind of a transistor. So high speed MOS transistor, which are N channel, N type. So you just need to know that it is made of a transistor that is HMOS category, N channel. Okay, so this is the transistor that is used to fabricate or to manufacture, to prepare the 8086 chip. Okay, this is the first point. Next is what is the speed of this microprocessor. So the speed is actually nothing but its clock frequency. So what is the clock frequency? The 5 megahertz is the basic clock frequency, but it has further two versions. So 8086 has total three versions. The other version has clock frequency 8 megahertz and 10 megahertz. So with respect to frequency, this clock frequency, it is faster than 8085. You can see that. Okay, 5 megahertz, 8 megahertz, 10 megahertz. So it is the clock frequencies of 8086 microprocessor. Next is how many pins are there in the chip of 8086 microprocessor. So how many pins are there? It has total 40 pins, right? It has total 40 pins. So this is also an important point, because in hardware perspective, 8086 microprocessor has total 40 pins. Okay. Now next important point is what is the size of address line and data lines. What is the need of address lines? Address lines is required to locate a memory space, and data lines are required to handle a data. So in 8085 we see that 8085 has 16-bit address lines and 8-bit data lines. That means through 8085 I can access address memory block. I can access the external memory block having a size 2 to the power 16, that is 64 kilobyte. Okay, that thing we have discussed when we are discussing 8085. But now in 8086 it has 20 address line. Okay, it has a 20 address line, and corresponding to that it has a 16 data lines. Okay, so these two factors, the address line and the data lines, are improved in 8086. You see, because the address line size is here 20, but in 8085 it is 16, and data line size is here a 16, but in 8085 it is a 8 bit. So both these two factors are improved in 8086 microprocessor. So this is a very important improvement that happened in 8086 microprocessor. Okay, so if now after this, the next point is, as it has a 20 bit address line. So 2 to the power 20, 2 to the power 20 means 1 megabyte. Okay, so 2 to the power 20 means 1 megabyte. That means that the memory space is 1 megabyte size. That means, as we know that memory block is not integrated part of microprocessor, it is a external part. So external memory block, when I connect with microprocessor, so that microprocessor can access that external memory block, each location of that external memory block. So when microprocessor is accessing each location of the external memory block, then we should know that what is the size of that external memory block, and the size of the external memory block is 1 megabyte. Okay, the size of external memory block is 1 megabyte. How it is coming 1 megabyte? It is coming as 20 address lines, so 2 to the power 20, that means 1 megabyte. Now in 8085 it is actually 2 to the power 16, and 2 to the power 16 means 64 kilobyte. Okay, 2 to the power 16 means it is 64 kilobyte. You can calculate by your own. Okay, so that means what we can see that in 8086 microprocessor we can connect our on a memory block. We can connect a memory block which has a greater size with respect to the 8085. Okay, that means in 8085 we can connect a memory block of 64 kilobyte with microprocessor, but here we can connect a memory block having size of 1 megabyte with the 8086 microprocessor. So this is also a improvement factor. Okay, next is we see that this this is actually not an improvement. Next point, it is actually the how this is the configuration. So in 8085 we have seen that there are 40 pins. In 8086 we see that there are 40 pins, but the thing is, here the address lines, number of address lines has been increased, number of data lines also has been increased. So the question is how increased data lines and address lines are accommodated in the same number of pin, because here you see the pin size, number of pins is fixed for 8085 and 8086. That means the manufacturing to manufacture 8085 or 8086 hardware chip, there is there is less same number of pins are manufactured. So to manufacture the pins, the cost is same. Okay, same, that is 40 pins. So but we have more number of address lines, we have more number of data lines. So how these extra data lines or address lines are accommodated in the same number of pin, 40 pins? To answer this question, it is written here. It is coming in the basic features category, that 16 lower order address lines are multiplexed with 16 data
Yeah.
lines. Okay, 16 lower order address lines are multiplexed with 16 data lines. Okay, so this is the way how it is possible, how so that we can accommodate more number of address lines and data lines in the same number of pin. That means we are using multiplexing technique. We can accommodate more number of address and data lines into the same number of pins. So here you see the 16 lower order address among that for 20 address lines, okay, are multiplexed with 16 data lines. Then 4 higher order address lines are also multiplexed with status signals. So that means all our things are multiplexed. So using multiplexing in 8086 we can have more number of address and data lines. Okay, and where the multiplexing process is applied, here it is applied as the 16 lower order address lines are multiplexed with 16 data lines, and 4 higher order address lines are multiplexed with 4 status signals. So this is the way we see. You see that the scheme is possible. Okay. Next is, it has in 8085 we have only single mode. There is no mode selection process, because in 8086 we have only a single mode of operation. Okay, so but in 8085 there is a single mode of operation, but in 8086 we have basically two mode of operation. Okay, so minimum mode and maximum mode. So you see that in this is the advantage of your 8086 microprocessor, can be used in a two different mode, minimum or maximum mode. So there are so many advantage we can note from these basic features that 8086 has. Okay, so first advantage, it has a uh, higher address line and data line pins. Second advantage, and it has a higher clock frequency with respect to 8085. Third advantage, it has higher memory space with respect to 8085. Fourth is it has a multiplexing process by which we can accommodate more number of address and data lines into the same number of pins, that is 40 pins. Then we have the two different mode of operation that is not present in 8085. So there are basically different this type different sector or different points where the 8086 is better than 8085. Okay, so from these basic features we can visualize that concept. And if I make a question like this, the question is, what are write down the differences or improvement of 8086, okay, 8086 with respect to 8085. Then you can also write down the answer, because from this these are the points where 8086 is improved with respect to 8085. Okay, so this is the basic features. Next is your pin configuration. So it has total 40 pins. We don't need to go to the each and every pin operation, because maximum pins are same similar to the 8085. Some four or five pins are different, so I have written only the important four essential four pins which are not there in 8085. Okay, so first one is your NMI, that is non-maskable interrupt request. Okay, and second one is interrupt request. This interrupt request pin is also there in 8085, but you see, as NMI also is not there, so I have written these two pins separately. NMI is there in 8086, which is used to access non-maskable interrupt request, and there is general interrupt request pin. Okay, then there is a BHE slash S7 pin. BHE is the basically bus high enable pin. Okay, that is used to enable the data bus, that is used to enable the data bus of D15 to D8, up to D15, from D15 up to D8 pins. Okay, so that means not complete data bus size is 16. Here only upper 8 bits are controlled by the BHE. Okay, so basically this pin is used to control the data bus. And next pin is your test pin. This test pin actually used to control the or check whether that 8086 person is performing well or not. So for testing purpose, for different testing purpose, different, after completing this any program to test the program or something like that, hardware testing part, it is used this pin. So in that test pin, this is not there in 8085, that's why I have written. So basically these four pins, among these four pins the interrupt request is there, but I have written, but these four pins are important pin in 8086. Okay, so test pin is there, that is very different, it is not there in 8085. BHE slash S7, NMI non-maskable interrupt request and interrupt request. So you just need to go and understand this four pin operation, four pins, okay, which are not there in 8086. So basically why I have written, I can ask you a small questions from here. Okay, what is the function of test pin, what is the function of BHE slash S7 pin, like this. Okay, so next is your operating mode. So 8086 is a microprocessor. Okay, this microprocessor can have maybe work in two modes, minimum mode and maximum mode. Okay, so what is actually minimum mode? Minimum mode means something is minimum. Maximum mode is when it is used in a maximum possible way. Okay, so basically it is like this: when only one 8086 CPU is to be used in a microcomputer system, the 8086 is used as a minimum mode. Okay, so that means 8086 microprocessor can be used in a two mode, that is minimum or maximum, or rather I can say in a system of single processing unit or multi processing unit. Okay, so if I say in this way, then it will be easier to understand that 8086 can be used in a two mode, in a single processing unit or multi processing unit. So why single processing unit? So it is written here, when only one, that is single 8086 processing unit, CPU is nothing but processing unit, is to be used in a microcomputer, the 8086 is used in minimum mode. And when it is used in multiprocessor system, when it is used in multiprocessor system, it is used in maximum mode. So when it is used in a multiprocessor system, it is used in a maximum mode. Now the question is, what is a multiprocessor system and what is single processor system? So so basically, the single processor system is a system where only single processor, that is 8086, exists or present, and it has to control each and every action of that system. Okay, so single processor system of 8086 is quite similar to the 8085 operation. Okay, so in 8085, what we have seen, yeah, 8085 is a using 8085, I can handle interrupt, I can handle DMA, direct memory access. Though that thing I have not discussed, but there is a provision. I can handle DMA, I can handle interrupt, I can handle memory related read write operation, I can handle input output related read write operation. Okay, I can handle I can handle demultiplexing using ALE, right? So these all things I can handle using 8085. So similar to that, in 8086, when it is working as a single mode operation, it can be used to handle all the basic operations of microprocessor. Okay, but what is multiprocessing system? So when multiprocessing system 8086 is used, okay, when in multiprocessing system the 8086 chip is used, so as the name suggests, multiprocessor. So there are more than one processors are there. So each and every processor are doing some specific task. Okay. So at that scenario, 8086 is not responsible to control each and every operation. Okay. So there 8086 has a specific task to do. So this kind of scenario also present in it, can be done or also present in 8086. So this is known as maximum mode operation. So in a maximum mode operation, 8086 is not the controlling processor, it is only a part of the system. But in a minimum mode operation, 8086 is the controlling processor, because there is only one processing unit is used, that is 8086. Okay, now next is when it is working in a minimum or maximum mode, its pin configuration means it has total 40 pins. Out of 40 pins, pin number 24 to 31, this 8 pins will be configured automatically in a different way. Okay, so that is the advantage of 8086 microprocessor. It can be used in two different modes, and when according to the mode, the pin number 24 to 31 will be configured accordingly. According to the mode, it will configured accordingly. Okay, so so we'll see how these pins are functioning. Okay, so suppose when 8086 is operating in a minimum mode. Okay, so as the name suggests, it is operating in a minimum mode. That means it has the control, it has the authority to control everything, right? It has the authority to control everything. So Abhishek Kumar, तुम्हारा microphone. Okay, so it has the authority to control everything. Okay, so when 8086 is operating in a minimum mode, it has the control authority to control everything. So this is quite similar to the 8085. Now you see the pin number 24 to 31, pin number, so you don't need to remember all the pin number which are associated with which, but you need to understand the concept here. So from pin number 24, the 8086 can handle interrupt. Pin number 25, it can handle the ALE, that means demultiplexing. From pin number 26, it can handle the data. So data is going, should we go or not go, something like that, it can handle the data. In pin number 27, and so data transmission or receiving operations, also it is controlling that part. Pin number 28, it is deciding whether the operation is memory related or input output related. Okay, pin number 29, it is deciding whether to write or not. From pin number 30 31, it is deciding for DMA operation, it is deciding hold where to send, whether to send hold acknowledgement signal or not, whether to hold or not. So basically you see from pin number 24 to 31, it is controlling each and every part. That basic part that we have already covered in 8085. It is controlling interrupt, it is controlling demultiplexing, it is controlling data flow, it is controlling memory related or IO related operations, it is controlling writing operations, it is controlling DMA operations. So basically the concept is, when it is operating in a minimum mode, it is control, it is the single control unit. So it has to control each and every operation. The operations are like your interrupt, your DMA, your memory related or IO related decision. Means whether any operation is memory related or IO related, that decision should be controlled or should be taken by the 8086. Whether to write or not, whether to read or not, that thing also decided, should be decided through 8086. On the flow of data, the demultiplexing of address and data bus, that part also decided through the 8086. So basically all these basic operations are controlled by the 8086, and this is coming in the category of minimum mode operation. Okay, so now move to the next one. So when 8086 is working as a maximum mode, okay, so it can be used as a maximum mode also. So before going to that part, you just write down your ID here. Okay, then I will discuss the maximum mode and I will end the class. So after maximum mode, the today's class will be over. So write down your ID. Okay, so now next is your 8086 microprocessor when it is working in a maximum mode. Okay, so at that time the pin, so pin number is starting from 24. So 24 to 31. So you see pin number 24 and 25. It is now actually used to to notify you the instruction queue status. Okay, actually it is now showing the status of the instruction queue. So there is an instruction queue in the block diagram of 8086. That queue status can be seen from these two pins. Okay, so qs1, qs0, 00, 01, 10 and 11. Okay, so this is the these two pins are used when 00, that queue is there is no operation. When 01, then first byte from the queue has been fetched, then 10, the queue is empty, then 11, then queue is subsequent bytes are fetched from the queue. Basically this is the status of the queue from pin number 24 and 21. So that means in 8086 it is not now it is using in the maximum mode. Okay, so as it is using in maximum mode, so it is not only the controlling part for the whole system. So in the maximum mode, that means multi-processor system, there are some other processors also. So 8086 is performing its own specific task, and that task, first of that task is to show the status of the instruction queue. So it is used pin number 24 and 25 for this purpose. Okay, and then from the this table we understand this status of queue. When these two pins are 00, there is no operation. When 01, it is first byte from the queue has been fetched. When 10, the empty the queue, then 11, the subsequent bytes are fetched from the queue. So this is the operation of or function of pin number 24 and 25. Next three pins are there: 26, 27, 28. So pin number 26, 27, 28. Now what is the function of these pins? So I have written here, this pin, these signals are connected with bus controller. So you see, as it is multi-processor system, so 8086 is all connected with the other processor, that is your bus controller. So that bus controller has the Intel 8288, that processor name. Okay, it is connected to the bus controller, and bus controller generate memory or IO related control signals after getting these signals from these three pins. Okay, so the point is, from these three pins, one second, one so point is, from the pin number 26, 27, 28, when microprocessor 8086 is working in a maximum mode, it is used to connect with bus controller, that is another processor, and from that processor, that bus controller will generate further signals. Okay, and these three pins, when it is connecting with the other processor, these three pins also have some information within it, right? So these three pins, transferring some information from 8086 to 8288. Okay, so what are that information that these three pins is transferring from 8086 to 8288, that we can understand from this table. Okay, so basically, when in 8086 is operating in a maximum mode, it is used in a multiprocessor system. It is connected with the bus controller, that is 8288. So through the pin number 26, 27, 28, it is transferring some information from itself to bus controller. So with that information, we can see from this table, this S2, S1, SD, from this table. So when it is 000, all this means value. So it is actually transferring the information that interrupt acknowledged. Okay, this information is transferred to the bus controller. When it is 001, then read from IO port, this information is transferred. When it is 010, write into IO port. When it is 011, halt. When it is 100, opcode fetch, this is the information is transferred to the bus controller. Then it is 101, memory read, 110, memory write, and 111, that is your passive state. So basically these informations are sent to the bus controller through these pins from 8086 when it is working in a multiprocessor system. So you understand that this kind of configuration are totally new in this 8086. It is not present in 8085. So this is actually kind of improvement of 8086. Okay, and then pin number 29, which is a lock pin. So whenever it is necessary to lock all the operations of 8086 microprocessor in multiprocessor system, the pin number 29 is used, okay, to lock. And pin number 30 and 31, these two pins are used to controlling local bus. So actually, in a multiprocessor system, the address bus of your the address bus of your, say, 8086. Okay, in a multiprocessor system, as there are multiple processors are there, so address bus and data bus of the 8086 become the local bus. Okay, so that local bus are controlled by your pin number 30 and 30. Okay, so basically this is the way, actually, this is the configuration way of maximum mode 8086 processor. Okay, so you can understand that this is the configuration way. These 8 pins are configured themselves in this manner when 8086 processor is used in a maximum mode, so that it can be used efficiently. Okay, so that's all for today. Okay, so just one second. If I now, okay, I will handle the question, just one second. So if I take a gist from this today's class, then first is, we understand that what are the improvements of 8086 microprocessor with respect to 8085 microprocessor from the basic features. Okay, then we see the some important pins of 8086 microprocessor which are not there in 8085. Then we see the operating modes of 8086 multiprocessor or single processor system, and how the pins are configured themselves according to this mode. Okay, so it's in minimum mode and in maximum mode. Okay, so this is actually the thing we have learned from today's class. Thank you. Now, the question. What is the question?